Hey boys and girls, it's Miss Holmes and Miss Atfield, and this is our Wednesday flip lesson. We are still working with multiplication, and we are going to move into multiplication input-output charts, which you guys should be familiar with or have heard us talk about because we did this with addition. So we wanted to just very quickly tell you these are two different ways that you can say input-outputs. We have vertical and horizontal, but the information, you guys can see it's the same thing. It's just one's coming in and what's coming out.
Okay, we wanted to remind you of some important things to remember when we're dealing with input-output tables or charts. The first thing is, just FYI, these are used to organize our data or our information. It's a way to organize our information to make it easier to understand. And our second bullet here reminds us that, and we've talked about this, but we want you to remember that the rule or the pattern in a table or a chart, it must apply to all the number pairs in a table. It cannot be the rule if it only applies to some of the number pairs. It has to work for all of them, all the way across or down the chart.
So we need to make sure that we are looking at every column and seeing if the pattern fits every column or row.
Yes.
Okay. So this is, Ms. Atfield just talked about how we do input-output charts just to collect some of our data. So we're going to look at this problem, and then you guys are going to help us create an input-output based off of the data we have in this problem. So Knox is planning his birthday, and he invites 7 boys, and he wants each boy to have 6 water balloons. So how many balloons does Knox need to buy? So the information to help us organize, we're going to do our chart, our graphic organizer that we've been working on to decide operations and total or differences. So we're going to take the information we know. So what did we know?
Well, based on the problem Mrs. Holmes just read, we know that Knox is inviting 7 boys to his party. So we're going to write that 7 boys have been invited. And we also know, from what Mrs. Holmes read, that Knox wants each boy to have 6 water balloons. So each boy needs 6 balloons. Okay? So that's what we know, Mrs. Holmes.
Okay, so and we need to figure out what we need to find out. So let's go and do our trick. Let's go straight to the question. The question is what we're actually looking for. So it asks, how many balloons does he need to buy? So that tells me that we are looking for a total. We're looking for a total.
Okay, well, if we're looking for the total, what are we looking for the total of? The total number of balloons that Knox needs to buy for his party. Okay, so that's what we're looking for. Sorry about that. I was writing and wasn't showing you while I was writing. Okay, so here our organizer is all filled out. We know what we already have what we know, and we know what we're looking to find out. The total number of balloons.
So we know that we're looking for a total, and that only leads us to 2 operations. We have our addition, and we also have our subtraction. So we need to decide. I'm sorry. I am so sorry. It is, hey, almost the weekend here.
Yes.
So multiplication. So we have to decide whether we're dealing with equal groups or not. And we talked about how we can simply draw a picture, a very quick sketch, to see if we can see those equal groups.
Yes.
So can we do that on our little graphic organizer over here?
Okay.
So it looks like 7 boys. So we know that is probably going to be like our groups,
4,
if we have
5,
groups.
6, 7. Okay, so each circle represents one of the boys.
Correct. And then if each boy needs 6, this boy would need 6.
Okay. I'm going to do like you've done, which is 5 and 1. Would that work?
I think, oh, it does work.
Or you could even put 6 in each circle if you would prefer to do that.
Miss Holmes likes to skip count by those 5s.
Why, Mrs. Holmes?
I know my 5s.
Aren't they easier to
They
count?
are easy.
Okay.
They are easy. So now we know what we know. We know what we have to find. We can tell that we are dealing with equal groups. So our table has to show a rule of multiplication and needs to show the increase.
Yes.
So let's draw our table, our input chart.
Okay.
So back to what we know. We're going to put just what Miss Alpha wrote, the boys invited and the balloons, the number of balloons.
Okay, so number of boys, and we're trying to figure out the relationship between the number of boys and
The number of balloons.
Number of balloons. And we've already talked about how we're going to be increasing. We're looking for the total because we have how many boys? We have 7. So.
And if we look at Miss Affill's picture, we know that one boy, so if we write one boy in our output and go back to her picture, inside her picture, this one boy had a total of 6 balloons.
6 balloons.
So the number of balloons this boy has is 6. So now we're going to look at a relationship. How did we go from 1 to 6? Well, Miss Affill told you guys that we have to make sure that we are looking at all of the
number of pairs.
So let's keep continuing before we go to the rule.
Okay.
So if one boy is 6, what would 2 boys be?
2 boys would be double 6, wouldn't they?
Well, based on your picture, we can always go back to our picture. We can always do a pictorial, which is easy too. So here's one boy with 6. Here is one boy with 6. And if we cover those 2, we know that 5 and 5 is 10 plus 2 more is 12.
Awesome.
So 12.
Okay.
So how many number of boys are we trying to get to?
We're going to 7. Shall I go ahead and fill that part out first?
Go ahead and fill out 7.
Because that's the total number of boys that he has invited. Oops. Mistakes are.
But you know what, Miss Affill? Sometimes
Oh,
they will skip like that. Once you
will.
find the rule, you can apply it, and it doesn't matter if it goes in order or not. So I think that's where your brain was going, that we normally see it not in order. Because once we find that rule, we can apply it. All right, so one boy is 6, 2 boys is 12. What is the relationship, Miss Affill?
well, I'm increasing from a smaller number to a larger number. We're increasing here.
So if I decided to add, 1 plus 5 gets me 6.
Right? It could be addition, but if it's plus 5, if the rule is plus 5, it has to work here too.
So you're saying I would have to say plus 5, my 2? Well, 5 and 2 is 7. Oh, that's 12. So I'm not adding.
So the only other way we can increase is using the operation of multiplication. So let's try it. So if we have one boy and how do we get to 6 if we're using multiplication?
Well, one group of 6 is how many? It's the same amount, so 6.
Exactly.
So I'm thinking maybe 6 is our rule. So let's try. We have to try with our next column.
Yes.
6 times 2. Well, we know our 2s are just saying 6 2 times, and 6 plus 6 is 12, so that actually works.
So 2, if I apply the rule of times 6, if I multiply this number here times 6, I will get 12.
12. So I think we might have found our rule.
Okay, and I could even show that. If I think that's our rule, I could even show that like this to show that that's the rule being applied to get the number of balloons.
So let's try one more from our pictorial, and then we can decide if that's truly our rule.
Okay.
So now we have a total of 3 boys, with each having 6. So we have 5 and 5 and 5 is 15, with 3 more is 18. So we have 3 boys who would have 18. So let's try it. 6 times 3. That means 6 plus 6 is 12, and 6 more gets us our 18. I think we have found our rule.
Okay.
So can you go ahead down here and write our rule times 6 like you did?
And I would encourage you to actually write the word rule and then tell us what the rule actually is. So we would say the rule is multiply the number of boys times, or you could do the multiplication symbol, times 6.
So, just to tell you earlier about Miss Affill making her mistake here, if she would have left it 6, would I have to do it in order of 5?
You would not have to do it in order if you knew what the rule was.
So I could simply just skip. If I am looking now for the total of 7 boys and our rule is 6, then I could say 7, and I'll put that there, 7 times 6, and we know that is 7 repeated 6 times,
Yes.
which gives us a total of 42. So once we have found our rule, we can apply it to any number. So tonight on your IMBs, we want you guys to solve this problem. 1 bag of beans has 4 red beads. 1 bag of beads, has 4 red beads. How many total beads do 6 bags have? So here we wrote, we want you to go ahead and write what I know, what we need to find out. And then once we figure out if we're going for a total or if we're finding a difference, then you have the choice of either doing a horizontal or a vertical input, but you need to put that operation once you find it and why, and making sure that you are putting that rule once you find it.
Yes, if you will, go ahead and write the word rule and tell us what your rule was for your table. And then don't forget, if you need the title for your table of contents, if you're not sure what to write, you can just write multiplication, input, output. Make sure you number your page and you put the date. And is there anything else I'm leaving out?
Nope, we'll talk about it more tomorrow.
Okay, we'll see you tomorrow, boys and girls.
Bye.